Good day, everyone. My name is Vin Dang, and I am the Marketing Director of CORACTIVE High Tech. First of all, I would like to thank the whole team of Epic Photonics to organize this second edition of Photonics Plus. And today, my presentation, I will be presenting optical fiber solution for LiDAR application. So for those who don't know, CORACTIVE is actually, we are a Canadian company. We were founded in 1998. We're headquartered in Quebec City, and our main focus is we are a manufacturer of optical fiber. We are also a fiber laser supplier. In terms of highlights, we are more or less over 60 employees. We've delivered more than 1,000 kilometers of optical fiber yearly, and we are the only supplier of phosphosilicate ytterbium doped optical fibers. And we have more than 17 years in optical fiber development, especially for high power fiber lasers. So when I say that we are a manufacturer, we are fully integrated, vertically integrated in terms of our manufacturing of optical fibers, meaning that we go from glass preform production all the way to the fiber lasers and components. So we have a complete control of our manufacturing process, which leads us to the highest level of quality at the lowest cost. Our markets, mainly CORACTIVE has a solution for the industrial applications such as laser cutting, laser welding, laser marking, engraving. We have also solution for the telecom business. We provide ATN attenuating fibers. We also have other type of solution for the telecom. And lastly, we also have a solution for the sensing application, which is basically all the fibers that I will be discussing with you today. And also for any other type of emerging application, if there's a need for any type of optical fibers, we can actually adjust and provide solution for these applications. In terms of LiDAR, what the market needs, there are two segments. So first of all, the LiDAR application, you have autonomous vehicles, you have wind sensing application, you have metrology, you have even defense applications. These are the various type of LiDAR application. For any LiDAR, you need fiber lasers. And for fiber laser, you need to have a perfect light source that has robustness, flexibility, efficiency, and thermal properties. These fiber lasers need to be achieving high peak power for longer distance detection. Of course, you have to operate in the eye-safe wavelength, which is at 1550 nanometers, and you also have to have an excellent beam quality. But to make those fiber lasers, you need optical fibers. And in terms of the needs of optical fibers, you need to have a long-term variability in harsh industrial environment. You need to have high absorption in order to minimize nonlinear effects while achieving those high peak power. And in order to achieve the 1550 nanometers wavelength, erbium ytterbium doped co-doped specialty optical fibers are the fiber of choice. So they play a critical role. And as I mentioned, there are other type of LiDAR applications such as wind sensing, where polarized maintaining or PM fibers are desired. So this is actually for one of the application, but there are many other applications where PM fibers would be more desired than non-PM version. So in terms of our co-dope erbium ytterbium, so these are the main advantages. Like first of all, we have our fibers have very high absorption. So we use a phosphosilicate matrix, which the advantage of the phosphosilicate matrix is that it shows low photo darkening, and pretty much what happens is that because of the high absorption, you need a shorter fiber length for designing your amplifier and laser. Secondly, it has a low amplified spontaneous emission, or ASC. So what happens is that we have optimized the composition design of our erbium ytterbium fiber. So basically what happens is that by optimizing this design, there's a balance between erbium and ytterbium, which then nullify or diminishes the amplified spontaneous emission. Because we are using a phosphosilicate matrix, there's also a high energy conversion. So there's a low cross section based on the phosphosilicate matrix, and it has a high population inversion. So, and overall, as I mentioned earlier, codope, erbium, ytterbium active fibers are ideal for operation around 1550 nanometers. In terms of the graph that you see on the right side, you actually do see the ASC spectrum, so of one of our fibers, and also the typical amplifier slope efficiency. For any type of fiber amplifier configuration, this is a representation of a typical amplifier configuration. So depending on your needs, depending on your design, more or less the pre-amplifier stage may be needed or not needed. Okay, so this is pretty much depending on the application. So as you can see, actually here there's a pre-amplifier stage, and then there's a power amplifier stage in which the erbium ytterbium codope fiber plays a critical role. So for those who are using a pre-amplifier stage, usually pre-amplifier stage are designed with erbium dope fibers. And in terms of the product that we have three products that are still preliminary, but we believe that these type of products are very good for the pre-amplifier stage. As you can see, we are talking about the single cladding fibers, so erbium 68-125-12, and then the 35-10-125-12, and we also have the erbium 35-7. When you go more into the amplifier stage, this is, as I said, this is where erbium ytterbium codope fibers are more critical. And I apologize, there is a little mistake here. This should be a double clad fiber EY 6-125-12 to reach up to 2 kilowatt of peak power. And the graph on the right, one of the main advantage of erbium ytterbium dope using a phosphosilicate matrix, from the graph that you can actually see here, if you look at the absorption curve, if you look at the absorption, it's actually pretty flat due to the phosphosilicate matrix. So what happens is that you can actually use pump diodes at 950 nanometers, but also you can use pump diodes at 940 nanometers. So both actually provide the same type of provide the same absorption in terms of phosphosilicate. You can pretty much use the same either pump diodes. And I know that and there are some advantages in sensing application using 940 nanometers. So afterwards, if you want to reach higher peak power, higher level of average power, then we offer different other type of product. For example, the DCF EY10-128, which is a 10 micron erbium ytterbium fiber. This is actually from the graph, you'd actually see the slope efficiency. This is around 37% of slope efficiency. Afterward, you also have the EY12-130 and then the EY16-128, which is one of the latest fibers that we have that can help achieve 5 kilowatt peak power. Depending on the fibers, you can either use them in a pulse operation or in continuous wave operation. And lastly, one of the last product that we have developed over the years is the DCF EY16-250 P, which is basically a fiber that allows you to go up to 10 kilowatt of peak power. So as I said, depending on your design, you may have one amplifier, two power amplifier. As I said, it all depends on the design. So you can use a combination of the different type of erbium ytterbium fiber in order to reach the desired peak power level. Lastly, we here at CORACTIVE, we also develop polarized maintaining type fibers. So we have single and double cladding fibers. For example, we have a version of the ER35-7 PM, which offers a very high absorption, and these are typically used for pre-amplifier stage. And then we have a double clad PM, which is, for example, a version of the a PM version of the non-PM version fibers. And usually these type of fibers have high absorption, high efficiency, have good beam quality, and again, can be used up to 5 kilowatt peak power designs. Again, one of the graphs that I show here is actually the efficiency, the slope efficiency of the of our 6128 PM version, which offers around 30% slope efficiency. So, with all of these type of fibers, knowing that the market is expanding, is changing continuously, we are also aware of that, and we are keeping our development in par with the change in the market. So what's coming next for CORACTIVE is that we are actually developing all glass type fibers, which will be released by the end of Q3 of 2021. Knowing that there are harsh application using harsh environment, we are adding our high temperature acrylic coating to our portfolio, also by the end of Q3 2021. And then for sure, with the increase of power and the increase of peak power needed, we are actually starting to develop large core fibers, such as a 25 micron, which should be which we should release by the end of the year of this year. Afterwards, we are looking more into a PM version of our all glass fibers. All glass fibers actually, it's actually one of the things that we're focusing more on by the end of this year and actually by next year. And the PM all glass fiber should be released by Q2 of 2022. And of course, we are going to get to have the polarized maintaining of large core fiber, which is by the end of Q4 of 2022. Thank you very much. And if there's anything, I'll be able to answer all the questions. I actually have a question here. Why is 940 nanometers pumping particularly good? In terms of the efficiency itself, it's the same as the 950 nanometers. Where it is more advantageous is actually the cost. The cost of 940 nanometers for design is actually less than 915, even less than 975 nanometers pumping. So it's all a matter of the pricing. All right. Well, thank you very much. And as I said, if there's any more questions, feel free to come and visit our booth, and then we'll be able to answer your question directly from there. All right. Thank you.